So Fourier series of functions of period 2l. So suppose f of x is a periodic function with period 2l in the interval c to c plus 2l. Then Fourier series of f of x is given by f of x is equal to a0 divided by 2 plus sigma n equal to 1 to infinite an cos n pi x divided by l plus sigma n equal to 1 to infinite bn sin n pi x divided by l. So this is the Fourier series of the function of period 2l. So where a0 is given by 1 divided by l integration from c to c plus 2l f of x dx, and an is 1 divided by l integration from c to c plus 2l f of x into cos n pi x divided by l into dx, and Bn is 1 divided by L integration from c to c plus 2L f of x into sin n pi x divided by L dx. So this is how we can find the value of a0, an and bn. Now let us discuss example related to this topic. So first example, find the Fourier series of the periodic function with the period 2 of f of x is equal to pi, where x varies from 0 to 1, and pi into 2 minus x, where x varies from 1 to 2. So here we will have to find the Fourier series of function which is defined by this. So here first of all we will find the value of n. So here comparing the interval that is 0 to 2 with 0 to 2l. So if we compare 0 to 2 with 0 to 2l, then 2l is equal to 2. So value of l will be 1. So value of l is 1. Now the Fourier series of f of x with period 2l is given by f of x is equal to a0 divided by 2 plus sigma n equal to 1 to infinite an cos n pi x divided by l plus sigma n equal to 1 to infinite bn sin n pi x divided by l. Now here value of l is 1, so it will be a0 divided by 2 plus sigma n equal to 1 to infinite an cos n pi x divided by 1, so it will be n pi x plus sigma n equal to 1 to infinite bn sin n pi x divided by 1, so it will be n pi x. Now we will find the value of a0. So a0 is given by 1 divided by l integration from c to c plus 2l f of x dx. Now here in this example value of l is 1. So here it will be 1 divided by 1 integration from 0 to 2, because here we will have to find the Fourier series of the function in the interval 0 to 2. So limit will be from 0 to 2 f of x dx. Now this can be written as integration 0 to 1 f of x dx. Now for 0 to 1 function is pi. So for this limit value of function is pi. So here we will replace f of x by pi for limit 0 to 1 plus integration 1 to 2. Now for this function is pi into 2 minus x, because whenever x varies from 1 to 2, then function is pi into 2 minus x. So it will be integration 1 to 2 pi into 2 minus x dx. So integration 0 to 2 f of x dx is divided into integration 0 to 1 pi dx plus integration 1 to 2 pi into 2 minus x dx. Now here first of all we will have to find the integration of pi with respect to x. So here pi is constant. So integration 1 dx is x. So it will be pi into x and limit will be from 0 to 1 plus pi, then integration of 2 with respect to x will be 2x minus integration of x with respect to x will be x squared divided by 2, because we know the formula that integration of x raised to n is x raised to n plus 1 divided by n plus 1, and limit will be from 1 to 2. Now here first of all we will replace x by 1, then minus we will replace x by 0. So it will be pi into 1 plus, here pi is common, so pi in bracket 1 plus, here replacing x by 2, so 2 into 2, so it will be 4 minus 2 square divided by 2, so 4 divided by 2, so it will be 2. Then minus lower limit, so for lower limit we will replace x by 1, so here it will be 2 into 1, so it will be 2. But because of lower limit, here it will be minus sign, so minus 2 then minus minus plus 1 divided by 2, because 1 square is 1, so 1 divided by 2. So if we simplify this result, then it will be 3 pi divided by 2, because here 4 minus 4, so it will be cancelled out, and 1 plus 1 by 2, so it will be 3 by 2. So 3 by 2 into pi, so it will be 3 pi divided by 2. So this is the answer of A0. Now we will find out an. So an is given by 1 divided by L integration from c to c plus 2L f of x into cos n pi x divided by L dx. Now here we know the value of n is 1. So it will be 1 divided by 1 integration 0 to 2 f of x cos n pi x dx. Their limit is 0 to 2 because we have to find the Fourier series of function from the interval 0 to 2. Now here integration 0 to 2 f of x cos n pi x dx is divided into integration 0 to 1. Now for this limit value of function is pi. So we will replace f of x by pi. So pi into cos n pi x dx plus integration 1 to 2. So for 1 to 2 value of function is pi into 2 minus x. So it will be pi into 2 minus x into cos n pi x dx. Now here pi will be constant and integration of cos theta is sin theta. Therefore pi will be as it is, and integration of cos n pi x will be sin n pi x divided by n pi, because their coefficient of x is n pi, and limit will be from 0 to 1. Plus pi will be constant, and here there are two functions. First function is 2 minus x and second function is cos n pi x. So here again we will use Bernoulli's formula. So here first of all we have to decide one function such that its successive differentiation is 0. So here we will choose 2 minus x, because successive differentiation of 2 minus x is 0. So here 2 minus x will be as it is, and we will take integration of second function, that is cos n pi x. So integration of cos n pi x will be sin n pi x divided by n pi, because integration of cos theta is sin theta, and here coefficient of x is n pi, therefore we will have to divide by n pi. Then minus, now we will take differentiation of 2 minus x. So derivative of 2 is 0 and derivative of x is 1. So here it will be minus 1. Then we will have to take integration of sin n pi x divided by n pi. Now integration of sin theta is minus cos theta. Therefore integration of sin n pi x will be minus cos n pi x divided by n pi, and n pi into n pi will be n square pi square. So it will be minus cos n pi x divided by n square pi square, and limit will be from 1 to 2. Now here first of all we will replace x by 1, because upper limit is 1. So if we replace x by 1, then here it will be sin n pi, and value of sin n pi is 0. So no need to write down that term. So now if we replace x by 0, then it will be sin 0, and value of sin 0 is 0. So no need to write down this term. Now here first of all we will replace x by 2. So here 2 minus 2, so it will be 0. So no need to write down this term. So here if we replace x by 2, then here it will be cos 2 n pi, and here minus minus minus, so it will be minus, then minus multiplied minus 1 multiplied by pi, so it will be minus pi divided by n square pi square, so it will be minus 1 divided by n square pi into cos 2n pi. Now if we replace x by 1, that is lower limit, so here sin n pi, and value of sin n pi is 0, and here it will be cos n pi, and value of cos n pi is minus 1 raised to n. So here it will be cos n pi divided by n square pi, because pi divided by pi square is 1 divided by pi. So an will be minus cos 2n pi divided by n square pi plus cos n pi divided by n square pi. There it is plus sign because there are 4 minus signs, because 1 minus is for lower limit, so it will be positive. So we know that value of cos 2n pi is 1, and value of cos n pi is minus 1 raised to n. And here if we take LCM, so here it will be 1 divided by n square pi in bracket minus 1 raised to n minus 1. So this is the answer of AN. Now we will find out Bn, which is given by 1 divided by L integration from c to c plus 2L fx into sine n pi x divided by L dx. Now here in this example value of n is 1. So here it will be 1 divided by 1 integration 0 to 2, because here interval is from 0 to 2 f of x sine n pi x dx. Now integration 0 to 2 f of x sine n pi x dx is divided into integration 0 to 1 pi into sine n pi x dx, because when x varies from 0 to 1 then f of x is pi, therefore we will replace f of x by pi, plus integration 1 to 2 pi into 2 minus x sine n pi x dx, because for this interval value of f of x is pi into 2 minus x. So here pi will be as it is, and integration of sine theta will be minus cos theta. So here it will be pi into minus cos n pi x divided by n pi, because coefficient of x is n pi and limit will be from 0 to 1. Now here pi will be constant, and here as you can see that there are two functions. So we will use Bernoulli's formula. So first of all we will have to choose the function whose successive differentiation is 0. Therefore we will choose 2 minus x. So first of all 2 minus x will be as it is. Then we will take integration of second function, that is sine n by x. So integration of sine theta will be minus cos theta. So this will be pi into minus cos n pi x divided by n pi, and limit will be from 0 to 1. Then plus pi in bracket 2 minus x will be as it is. Then integration of sine n pi x. Integration of sine n pi x is minus cos n pi x divided by n pi, because coefficient of x is n pi. Then minus, we will take derivative of this bracket. So derivative of 2 will be 0 and derivative of x will be 1. So here it will be minus 1. Now we will take integration of this bracket. So integration of cos theta is sine theta. So integration of cos n pi x will be sine n pi x divided by n pi, because coefficient of x is n pi. So n pi into n pi will be n square pi square. So here it will be minus sine n pi x divided by n square pi square, and limit will be from 1 to 2. So here first of all we will replace x by 1. So it will be minus cos n pi divided by n pi. So here pi will be as it is in bracket minus cos n pi divided by n pi. Then we will replace x by 0. So it will be cos 0 divided by n pi. But here we are applying lower limit. So minus and 1 minus is of lower limit. So it will be plus. So cos 0 divided by n pi. Then this pi will be as it is. Now we will replace x by 2. So here 2 minus 2. So it will be 0. So no need to write down first term. Then here if we replace x by 2, then it will be sine 2 n pi, and value of sine 2 n pi is 0. So no need to write down second term. Now we will apply lower limit. So for that replacing x by 1. So here 2 minus 1. So it will be 1 cos n pi divided by n pi. Here it is minus sign, but 1 minus is of lower limit, so it will be plus. So cos n pi divided by n pi. And here if we replace x by 1, then it will be sin n pi, and value of sin n pi is 0. So no need to write down this term. So finally it will be pi in bracket minus cos n pi divided by n pi plus cos 0 divided by n pi plus pi into cos n pi divided by n pi. So here if we simplify this result, then here it will be minus pi cos n pi divided by n pi, and here it is plus pi cos n pi divided by n pi. So first and last term will be cancelled out. So here pi into cos 0 divided by n pi, and value of cos 0 is 1. So it will be pi divided by n pi. So pi will be cancelled out. So it will be 1 divided by n. Therefore answer of Bn is 1 divided by n. Now as we have to find the Fourier series of the function f of x. So Fourier series of the given function in the interval 0 to 2 is given by f of x is equal to a0 divided by 2 plus sigma n equal to 1 to infinite an cos n pi x plus sigma n equal to 1 to infinite bn sin n pi x. Here in this example value of n is 1. Now we have already found the value of a0, an and bn. So we will put the value of a0, an and bn in this Fourier series. So it will be 3 pi divided by 4 plus sigma n equal to 1 to infinite 1 divided by n square pi in bracket minus 1 raised to n minus 1 into cos n pi x plus sigma n equal to 1 to infinite 1 divided by n into sin n pi x. So this is the Fourier series of the function f of x, which is pi for 0 to 1 interval and pi 1 to minus x for the 1 to 2 interval. So in today's lecture, we have discussed about Fourier series of periodic function with period 2l, and we have discussed one example. Thank you for watching this lecture. I will see you in the next lecture.